Okay, let's take a look at these from 6.7. Applications. Now, this first question, an hour and 30 minutes is just 90 minutes. That's all you're going to do. Put t equals 90 and put that in your calculator. Just don't make mistakes. Question 2, similar here. When t equals 0, put it there, calculator. When t equals 15, put it for t. Use your calculator. Just try not to make mistakes. Now, C is the tricky one. So here we go. How long does it take to reach 2,000 fish? Okay, so what we're saying here is the population, left-hand side, P, is 2,000. 3587 over 1 plus 4.7 e to the negative 0.26 t. I have to find t. Looks awkward, okay? Well, the point is here is that I'm going to to get rid of denominators, if I want to get rid of all of this, I'm going to multiply both sides by it. In other words, this will end up here and will cancel on the right-hand side. So if this 2,000 is kind of next to all of this that I've put up here, if I divide both sides by it, I will end up with this. Look, basically what I've done is switched the numerators and denominators. This is now a numerator on the left-hand side, and the 2,000 is the denominator on the right-hand side, okay? Basically what I've done is I've just switched these two, okay? Now, if I put this in my calculator, let's have a look. 3587 divided by 2,000. Cancel. 3587 divided by 2,000 equals 1.7935. Okay, so 1.7935. So all of this equals 1.7935. Okay, so I'm going to erase get some space, a bit tight up here actually, because what I've actually now got is this. Okay, so 1 plus 4.7 e to the negative 0.26t equals 1.7935. Okay, I just divided that by that to get 1.79. So it's like I'm going to take away a 1. Okay, if I take away a 1 from both sides, I'm going to erase that. And of course, what I'm going to do is erase 1. All right, let me just write that again. So equals 0.7935. I just took away 1 from both sides. I'm now going to divide both sides by the 4.7 to get rid of that. So again, I'll just erase this. That's going to go. Okay. But what is, right, 0.7935 divided by 4.7 equals, right, that's 0.1688. I'll leave it at that, okay? Okay, so that's still e negative 0.26t equals that. So remember, log both sides. Natural log, because this becomes just negative 0.26t. This is still that. So if I hit the natural log of this, so here we go, the natural log, and then divide it by negative 0.26, because that's the number of the next letter, looks like I get 6.8, or about 7 months. Okay, if it wants it to hold numbers. And that's about right, because I think for this one, if you put it, I think in class we got something a bit over 3,000, something like 3,200 or something after 15 months. So that makes, so after 7 months, about 2,000. That sounds about right, okay? So 7 months for that. Okay, let's take a look at some more in here. Right, okay, so, okay, this one here. But by the way, I should have done this. Estimate the carrying capacity. Now, carrying capacity is the limit, like population can get to, okay, like on the planet or in this pond. Now, that is just this. This, if the carrying capacity, if you go to infinity, if you go time into the future, this will tend to 0. In other words, this will just be 3587 over 1, which of course is just 3587. I've seen some questions where, I think there's one I saw which was something like, supposing you had the numerator of 600, and it had 2 plus, I don't know, let's call it 3.2 e to the negative 0.26t, whatever, okay? Again, because this tends to 0, the carrying capacity would be 300, because there's a 2 there. But most of the equations have 1 there, okay? The carrying capacity always tends to be the numerator. But watch it if you've got something else. I think like maybe question 5 is on this homework, I'm not sure. Okay, so there's that one done. Let's move on to this one here, question 3. Okay, now, half-life. Right, because we use A equals A0e to the kt for most exponential growth, whether it's population or even decay, population growth, k would be positive, decay, k is going to be negative. So let's take a look at this. Half-life formula is just this. Half equals e to the kt, because this is just going to cancel out, and one's half the other, okay? So you're going to have that. So what we've got here is the half-life is 3.23 minutes, so that's going to be t, okay? So this is the half-life formula, so I have this. A half equals e to the k times 3.23. Just log both sides. Seriously, just log both sides here. Okay, so we're going to have the log of a half, 0.5. It's going to be, remember, if you log the right-hand side, you're just going to have the 3.23k, just the exponent. Remember that? When you log that, the base is the same as the e, because it's natural log. Okay, so let's take a look in the calculator. We have 0.5. I'm going to hit natural log. I'm then going to divide it by 3.23 because that's the number next to the letter. K equals negative. Remember, it's decay, it's going to be negative 0.214. I'll just call that 6. That's what K is. Okay? So, if we initially have 6... Right, here we go. So if we initially have 6144, how many half-lives will pass until 6 grams remain? Okay, so what I'm going to do now is this. If I now know what K is, I can do this. We have initially 6144 grams. In the future, we're going to have 6 grams. I do know that this now is negative. Sorry, that should be negative. 2146. And I'm now looking for T. Okay? So, from the formula. Again, remember, A equals A0e to the kt. I know this, that's 6,144. I know this, it's 6. I found out what K was. So now, again, I'm probably going to... Okay, what's happened to the E? That should be E there. Okay, so, I'm going to divide both sides by 6144. 6144, okay? Sorry about missing the E off. Right there, okay, right there. Right, cancel. 6 divided by 6144 equals, this is 0.0009765. 6, if you want to keep on going. Equals, again, remember you log both sides, this is just the exponent, negative 0.2146. Okay? So, if I log, sorry, I meant that log this, so I'm going to log this, the log of that is negative 6.93. If I divide it by negative 0.2146, I get 32, right, I get 32.3 minutes. Okay? That's what I get for doing all of this. Now, can you see that's a very nice number because this is how it wants it. How many half-lives? That is 10. You see, it's just 10 times bigger than that. So it's 10 half-lives. Then the length of time is, this is a bit silly question really, because how many half-lives is 10? The length of time is the 32.3. So that's how that works, okay?